Hello everyone. My name is Kumar Reddy and presently working with the Venkateshwara College of Engineering, and the course code is BCES 301 and the course name is Mathematics for CSE. Now we are going to learn about the topic of Introduction to Completely Randomized Design. Introduction to Completely Randomized Design involves in completely randomized design. CRD is a widely used experimental design in statistics. In CRD, treatments are assigned randomly to experimental units. The main objective of CRD is to compare the mean response to different treatments. Now, assumptions of completely randomized design. Homogeneity of variance assumption states that the variance of response variables must be the small across all treatment groups. Independence assumption assumes that the observations within each treatment group are independent of each other. Normality assumption states that the response variable should follow a normal distribution within each treatment group. Experimental setup and randomization. Randomization is the key to CRD to minimize potential bias and to ensure unbiased treatment comparisons. Experimental units are randomly assigned in different treatment groups. Randomization helps to control the potential confounding factors and reduce the impact of systematic errors. Hypothesis and statistical model. In CRD, hypotheses are formulated to test difference between treatment means. The statistical model of CRD assumes that response variable can be modeled as a linear combination of treatment errors, error team, and constant term. The mode in Yij is equals to mu plus Ti and Eij, where Yij is the response variable and mu is the overall mean, and Ti is the treatment effect, and Eij is the random error. Analysis of variance, which is also called as ANOVA, ANOVA. ANOVA is used to analyze the difference between treatment means in CRD. ANOVA decomposes the total variation in the response variable into treatment variation and residual error variation. The F test is commonly used to test the significance of treatment effects. Sum of squares and mean squares. Sum of squares SS measures the total variation in the response variable, and mean squares MS is obtained by dividing the squares of by the corresponding degree of freedom, and MS is used to estimate the variable components and to test the significance of treatment effects. Degree of freedom. Degree of freedom DF represents the number of independent pieces of information available from estimating parameters. In CRD, the total DF is the sum of the treatment DF and the residual DF. Treatment DF is equal to the number of treatment groups minus 1, while residual DF is equal to the total number of observation minus the total DF. Calculating F statistical and P value. F statistic is calculated by dividing the treatment mean square by the residual mean square. F statistic follows the F distribution under the null hypothesis. The P value is the probability of obtaining an F statistic and as extreme as the observed value, assuming the null hypothesis is true. Interrupting results and making interference. If P value is less than the chosen significance level, for example 0.05, we reject the null hypothesis and conclude that there are significant difference between treatment means. Post hoc test can be performed to determine which treatment means are significantly different from each other. Confidence intervals can be constructed to estimate magnitude of treatment effects. So in conclusion, completely randomized design, that is CRD, is a powerful and flexible experimental designing comparing treatment means, randomization errors, unbiased treatment comparisons, and controls the potential confounding factors. Analysis of variance, which is also called as ANOVA, is used for the treatment of significance of the treatment effects and making meaningful interferences. Thank you.